Hi, my name is Bashar Abdullah. I'm a product line architect for the packet networking portfolio. I'm going to walk you through demonstrations of Ciena's ventures into the virtualized network. There are a number of models for deploying services in a network. The first of those models is the traditional model we're familiar with, in which physical devices are deployed at customer prem sites and daisy-chained into various combinations to deliver services to customers. Now, we're going to demonstrate that just to show the facility of deploying these physical devices, and then contrast that with how we would do that in a virtualized network. So what we're going to first do is show the router, the physical router that we want to deploy at a customer prem site. So that wireless router would typically be shipped out to a customer site. A technician would have to go and deploy the physical device. They would power it on, they would interconnect it to the UNI of the service provider. They would go in and start configuring the device, and they would initiate some sort of service activation testing in order to validate that the service is configured correctly with the right SLA parameters and the service is connected. Now, that takes considerable technical effort to deploy and time. Now, once that service is deployed, the customer can then turn up their application. Now, we're going to get my colleague Pratyaya to demonstrate the service connectivity. So the service that we're referencing originates at a camera, so a camera that we've connected into the network. There's a physical router at that end that connects it into our packet transport network. And at the customer site, we're labeling it as Office 1. That's where we have our physical router. And the physical router is what I demonstrated being physically deployed. Could be daisy-chained with a number of additional services, such as firewalls or WAN optimizers. In this case, it's just a single physical router. Now, the service extends between the NID at the Office 1 and the headquarters site where the camera is located. Now, to demonstrate that we have connectivity using the traditional service deployment model, we can pan to the iPad that shows the actual video output from the camera. And we have bidirectional control, so we have bidirectional flow for that service, and we can control that just by initiating some control from the iPad itself. So now I'm going to present Model B. Model B starts introducing the concept of virtualizing services. The context for service virtualization for Model B is all these services you're typically deploying as a CPE device, such as routers, firewalls, WAN optimizers, encryptors. Those can now be virtualized as software entities on commercial off-the-shelf servers. If we pan to the slide to show the network context, so now we've taken our existing network where we demonstrated the video camera distributing a video stream. We've extended that service to a second site. We've labeled it as Office 2, where we have, again, another physical NID. The physical NID remains the specialized hardware accelerated forwarding path for the service, but now we're adding an x86 server subtended off that NID to provide the virtualized services at the CPE. And here we have an x86 server that is hosting Ciena's vSwitch. It's our virtual switch. It's running on top of Ciena's hypervisor and Ciena's operating system, its base operating system that is optimized for the networking industry. Now, one of the services that is being demonstrated as being virtualized is the virtual router. So what we've done now is taken that physical router and turned it into a software entity that can run on an x86 server. Now, to demonstrate this capability, we're going to show again that same video stream coming from the camera being distributed to that site. Now, what we expect is the same output we would see on the tablet in the traditional service deployment model is replicated using the virtual server model. So that's demonstrated here on this PC screen. And again, we can demonstrate control from our iPad. So the next model we want to demonstrate is Model C. Model C is taking Model B, but integrating that server component into the same NID device, leveraging the same hardware acceleration that you get with a physical NID, but with the ability to extend the platform with a server capability. So now we're talking about an integrated server onto a physical NID device. Ciena is introducing the 3906 MVI to enable the extension of a physical NID in the field using a field replaceable unit where a customer can physically deploy an x86 server as a plug-in option into the physical NID. We're going to demonstrate that in Model C here. So again, referencing our camera service deployment, we're going to extend that service to a third office which hosts a 3906 MVI. Now with the MVI in this particular demo, we have added the server blade, and with that server blade, it is an open architecture such that you can deploy Ciena's virtual switch that is optimized for networking, or you can choose any other industry available switch, open source or otherwise. In this particular case, we're demonstrating the open architecture using OVS, again hosting the vRouter VNF as the NFV enabled function. So we're going to go to TV1 to see the video output from that camera. So what we're demonstrating here is the video output of the camera on the third site, which is the integrated virtualized server on a physical NID, which is the Ciena 3906 MVI. Again, to demonstrate the bidirectional connectivity of the service and the ability to control that from any point in the network. So at Office 3, where we have the 3906 MVI, it demonstrates the integrated solution of the x86 server with the physical NID. What we've implemented for the demo is the OVS, the open source virtual switch, OVS, hosting the vRouter VNF, and it is running on top of KVM as the hypervisor and running on top of Linux Ubuntu. So finally, we're going to show you the last model where we've gone to a completely virtualized environment, where we've now subsumed not just the CPE services, but the physical NID as well, and virtualize that into a software instance that can be implemented on, again, an x86 commercial off-the-shelf server. Now, in this case, this is Model D. We're simply running an available x86 server with Ciena's vSwitch, and Ciena's vSwitch is running on top of Ciena's OS and hypervisor. And again, it's hosting the same vRouter, but completely in a virtual environment. So now we're operating a virtual NID. And we're going to demonstrate again on the final TV the same output from the camera, and demonstrate that you can achieve the same service outcomes with any of these deployment models. So we're demonstrating the video output of the camera on TV2. And this demonstrates the ability to deliver virtualized services in the same consistent manner, but more efficiently and with more flexibility than we are traditionally used to deploying Model A, which is the physical CPEs and the physical NIDs. Now, despite the flexibility of Model D, which gives you the full flexibility of a NID and CPE services on an x86 server, there are performance and cost considerations when going to higher bandwidth applications. So just to recap, what we've covered is the 4 different models for deploying services. The traditional model of Model A, in which the physical devices are deployed at the customer prem site, connected into a physical NID. Model B, which is the physical NID remains deployed, but now all the CPE functions and services are deployed as virtual services on an x86 server, in which, again, the Sienna virtual switch, hypervisor, and base OS can be deployed. We've demonstrated Model C, which is the integrated x86 server with the physical NID to achieve the same performance and cost points for higher bandwidth applications, but with the flexibility of extending support for virtualized services on the single platform. And finally, the completely virtualized environment in which the x86 server hosts not just the CPE services, but the NID functionality as well as a virtual NID instance.